In 1995, astronomers confirmed the existence of a star that, according to everything we understood about the universe, simply should not be there. Not because it was strange, not because it behaved oddly, but because of its age. This star is older than the universe itself. That single data point sat like a splinter in the mind of astrophysics for years, uncomfortable, unresolved, quietly threatening to unravel decades of cosmological certainty. Because if one star can be older than the cosmos that created it, then either our understanding of stellar aging is wrong, or our understanding of a universe's age is wrong. Or both. This is the story of HD 140283. A star so old, so improbable, so cosmologically disruptive that scientists gave a name that tells you everything you need to know about how it made them feel. They called it the Methuselah Star. To understand why this star is so disturbing, we need to understand how we age stars at all. Stars don't come with timestamps. We can't drill into them. What we can do is read them. Every star is a nuclear furnace burning hydrogen into helium at a rate determined almost entirely by its initial mass. Measure its luminosity, temperature, and chemical composition, and you can work backwards to its birth. It's not a guess. It's physics. Precise, testable, reproducible. When astronomers applied this method to HD 140283, the number came back at 16 billion years. The universe is 13.8 billion years old. The reaction wasn't wonder. It was alarm. A star cannot predate the universe that created it. The ingredients for stars didn't exist 16 billion years ago. The universe was nothing. And yet here was this star 190 light years away in the constellation Libra, practically in our cosmic backyard, burning with an age that broke the timeline entirely. The first instinct of science is not to accept the impossible, it is to find the error. Astronomers recalibrated instruments, re-examined models, questioned every assumption in stellar evolution theory. What they found was a star that kept insisting on its own impossibility. The answer lay in its chemistry. HD 140283 is almost entirely devoid of heavy elements. In astronomy, anything heavier than hydrogen and helium is called a metal, carbon, oxygen, iron, all of it. Our sun is metal-rich because it formed from the recycled debris of earlier stellar generations. HD 140283 contains almost none of that inheritance. It formed from near-pure hydrogen and helium, the raw output of the Big Bang itself. This makes it a second-generation star, a direct inheritor of the universe's very first stellar explosions. When we read its chemistry, we are reading a forensic record of stars so ancient that the universe erased every physical trace of them, except the faint signature they left inside this one survivor. In 2013, the Hubble Space Telescope refined its age to 14.46 billion years, with a margin of error of plus or minus 800 million years. At its upper bound, 15.26 billion years. The universe is 13.8 billion years old. Even at the lower bound, star sits at the absolute edge of what the timeline permits. Almost no time between the birth of the universe and the birth of this star. This is where the story becomes something larger than one strange star. The gap between HD 140,283's age and the universe's age exposes a genuine crack in cosmology, one scientists call the Hubble tension. The age of the universe is calculated from the Hubble constant, which measures how fast the universe is expanding. Different measurement methods keep returning different values. The disagreement won't resolve. If anything, as precision improves, the tension sharpens. If the universe is expanding faster than our models suggest, it is younger than 13.8 billion years. That makes the Methuselah problem worse. If it is expanding more slowly, the universe could be 14 or even 15 billion years old, which finally gives this star enough room to exist without breaking the model. Nobody knows which is correct. The star sits at the center of that uncertainty, applying pressure to our entire cosmological framework every time someone measures it. HD 140283 formed when the universe was barely 200 million years old. Our sun didn't form for another 9 billion years after that. Earth didn't exist for the first two-thirds of the universe's life. This star was already billions of years old before the atoms in your body were forged. It has watched the first galaxies form and evolve. It witnessed entire stellar generations live and die. It existed while planets coalesced, while life appeared somewhere in the dark, while one species on one small world built telescopes precise enough to finally read its age. And throughout all of it, this one star in Libra simply continued to burn. It sits there tonight, 190 light-years away, visible with a modest telescope. A 7th magnitude star. If you know where to look, you can point an instrument at it and collect photons from a nuclear furnace older than everything around it. Older than Earth by 10 billion years. Older than the Sun by 9 billion. We keep measuring. We refine the models. We let the tension do what good scientific tension is supposed to do, force us to look more carefully, question our assumptions, accept that our picture of the cosmos is still incomplete. But the star doesn't wait for us to catch up. It formed from the raw materials of the Big Bang. It survived the universe's most violent early chapter. It has watched 13 billion years of cosmic history unfold around it while remaining almost unchanged. And right now, at this moment, while you are watching this, it is still burning. Still there. Quietly impossible.